Hey there, science fans. Ever wonder what happens when you microwave strange things? We've all been there, staring into the humming box of mystery. Today, we're talking about a popular experiment microwaving grapes. Now, I'm not saying you should try this at home. In fact, it's pretty dangerous. But there's some amazing science behind it. It all starts with tiny electromagnetic waves and a whole lot of juicy potential energy. You see, grapes, those little bundles of sweetness, have a secret. They're full of water and electrolytes, which makes them react to microwaves in a very specific way. Intrigued? Let's dig in. Grapes are like tiny water balloons, but instead of rubber they have thin skins holding all that juice. Imagine biting into one and feeling that burst of flavor and liquid. It's like nature's candy, refreshing and sweet. But there's more to these little fruits than just their juicy goodness. Now remember what happens when you microwave water? It heats up. The water molecules start to move faster and faster, creating heat. This is a basic principle of how microwaves work. They excite the water molecules, causing them to vibrate and produce heat. But what if we told you that grapes take this process to a whole new level? But grapes have a little extra going on. Inside each grape are electrolytes. These are like tiny electrical gateways. These electrolytes are essential for various biological processes, but in the context of microwaving, they play a unique role. They help conduct electricity and can interact with microwaves in fascinating ways. When microwaves hit these electrolytes, things get interesting. The electrolytes start to oscillate and create hotspots within the grape. This interaction is not something you see with just water alone. It's the combination of water and electrolytes that makes grapes so special in a microwave. The grapes become little antennas, channeling the microwave energy in a surprising way. They can focus the energy into specific points, creating intense heat spots. This is why you might see sparks or even small flames when microwaving grapes. It's a unique phenomenon that showcases the intricate dance between microwaves and the grape's internal structure. This is where the real fun begins. The combination of water and strategically placed electrolytes makes grapes incredibly good at focusing microwaves into a very small point. This focused energy can cause the grape to heat up rapidly and even produce plasma, a state of matter where gases become ionized and conductive. Think of it like a magnifying glass focusing sunlight into a powerful beam. Just as the magnifying glass can concentrate sunlight to a point that can start a fire, the grape can concentrate microwave energy to create intense heat. This fascinating interaction is a perfect example of how everyday objects can exhibit extraordinary properties under the right conditions. Before we go further, let's get one thing straight. Microwaving grapes is risky business. It can damage your microwave, start a fire, and even cause harm. So unless you're a trained professional with a controlled environment, please don't try this at home. But if you're as curious as I am, you're probably wondering how it works. Well, imagine this. You have two grapes, almost touching inside the microwave. The microwaves bounce around, exciting the water molecules inside. As the energy builds, something amazing happens. A tiny, superheated channel forms between the grapes. This is where the real magic begins. But to understand it, we need to talk about plasma. Section 4. Microwaves and water molecules. A dance of energy. In this section, we will explore the fascinating interaction between microwaves and water molecules, and how this interaction leads to the creation of heat and even plasma. Microwaves are a type of electromagnetic radiation, just like light and radio waves. These waves are part of the electromagnetic spectrum, which includes a range of different types of radiation, each with its own unique properties and uses. While light waves are visible to the human eye, microwaves are not, but they play a crucial role in our daily lives, especially in the kitchen. When microwaves encounter polar molecules, such as water, they cause these molecules to vibrate rapidly. This vibration is due to the fact that polar molecules have a positive and a negative end, and the microwaves cause these ends to move back and forth. This movement generates kinetic energy, which we perceive as heat. This vibration creates heat, which is why your leftovers get warm in the microwave. The microwaves penetrate the food and cause the water molecules within to vibrate, heating the food from the inside out. This is why microwaving is such an efficient way to reheat food, as it directly targets the water molecules. But in the case of grapes, the shape and composition focus the microwaves into a very small space between them. When two grapes are placed close together in a microwave, the microwaves become concentrated in the tiny gap between the grapes. This concentration of energy leads to some interesting and unexpected results. This creates an intense electric field. The concentrated microwaves generate a strong electric field in the small space between the grapes, which can cause the air molecules in that space to become ionized. This ionization process is what leads to the creation of plasma. Think of it like a microscopic tug-of-war between the two grapes, with the microwaves pulling on the water molecules. The intense electric field causes the water molecules to be pulled in different directions, creating a dynamic and energetic interaction. This tug-of-war is so powerful that it can strip electrons from the atoms in the air. This tug-of-war gets so intense that it strips electrons from the atoms in the air, creating something truly spectacular. Plasma. Plasma is a state of matter where the gas becomes ionized and conducts electricity. This phenomenon is not only fascinating to observe but also demonstrates the incredible power of microwaves and their ability to transform ordinary materials into something extraordinary. Section 5. From hot to plasma sparks in the microwave. Have you ever wondered what happens when you put certain objects in the microwave? Today we're diving into the fascinating world of plasma and how you can witness this incredible phenomenon right in your kitchen. Plasma is often called the fourth state of matter. While most of us are familiar with solids, liquids, and gases, plasma is a bit more elusive. It's not something we encounter in our daily lives, but it's all around us in the universe. It's different from solids, liquids, and gases. Solids have a fixed shape and volume, liquids have a fixed volume but take the shape of their container, and gases fill the entire volume of their container. Plasma, however, is a whole different ballgame. In plasma, atoms are stripped of some of their electrons, creating a mix of ions and free electrons. This process is called ionization, and it requires a lot of energy. When enough energy is supplied, the electrons break free from their atoms, resulting in a soup of charged particles. It's superheated, electrically charged, and glows brightly. You've seen plasma before. It's not just a scientific curiosity, it's a part of many natural and man-made phenomena. Lightning is a dramatic example. When a bolt of lightning streaks across the sky, it's actually a massive discharge of plasma. The air around the bolt becomes ionized, creating that brilliant flash of light. The northern lights are also caused by plasma. When charged particles from the sun interact with the Earth's magnetic field, they create stunning displays of light in the polar regions. This is another beautiful example of plasma in action. And yes, that spark between the grapes? That's plasma too. When you place two grapes close together in a microwave, the intense energy causes the air between them to ionize, creating a tiny ball of plasma. This tiny ball of plasma is created by the intense energy focused between the grapes. The microwaves excite the water molecules in the grapes, generating heat and causing the air to ionize. It's a miniature version of the same process that creates lightning and the northern lights. It's super hot and can reach temperatures of thousands of degrees Fahrenheit. This is why you should never try this experiment without proper precautions. The temperatures involved can be extremely dangerous. That's hotter than the surface of some stars. Plasma is an incredible state of matter, and it's amazing to think that you can create it with something as simple as a microwave and a couple of grapes. So next time you see a spark, remember, you're witnessing the power of plasma. Section 6. The dangers of great plasma, more than just a mess. Now you might be thinking, wow, cool sparks, but remember, we're dealing with extremely high temperatures and volatile reactions. This isn't just a fun light show, here's why it's dangerous. First, the plasma can ignite flammable materials in your microwave. That means a potential fire hazard. Second, the intense heat can damage your microwave itself. We're talking melted parts and potential electrical shorts. And lastly, even if you avoid those dangers, the rapid expansion of air from the plasma can cause a small explosion. This can send hot grape bits flying, potentially causing burns. Section 7. Enjoy grapes the safe and tasty way. So, there you have it. The science behind those mesmerizing grape sparks is truly fascinating. But remember, science is best enjoyed safely and responsibly. Microwaving grapes can be dangerous, so leave those experiments to the trained professionals. Instead, enjoy your grapes the old-fashioned way, washed, chilled, and maybe even dipped in some delicious yogurt. Remember, science is all around us, even in the simplest everyday things. Stay curious, but always stay safe.